So from the CSC questions, I was given number 78, which says read a FASTA file and count the number of nucleotides in a microbial genome. So for my code here, I'm giving on the first column def column underscore nucleotides from fertile open bracket the 5 parts nucleotides underscore count equals to open A0 T0 G0 C0 N0. Now jumping down to 4, then we're having with open bracket 5 part R as FASTA file. On the row 5, we're having for line in FASTA file. In row 6, we're having line equals to line stripe underscore upper. Row 7, we're having if line does start with, like that's greater than 8, we're having continue. 9 for nucleotides in line. 10 if nucleotides in nucleotides count. 11 nucleotides underscore count, that's nucleotides plus equals to 1. 12 we're having else. 14 we're having nucleotides underscore count nucleotides equals to nucleotides underscore count get nucleotides 0 plus 1. 16 return nucleotides underscore count. And 20 we have the 5 part equals to your file FASTA. And number 21 column 21 we have count equals to count nucleotides from FASTA 5 part. And from 22 we having print nucleotides count. And row number 23 we're having for base count in count.item in brackets. And for 24 we're having print. This is the final stage at which we're going to be printing our code, which we're having base equals to count bracket and bracket. And this 24 is going to be the final column whereby we'll be printing all of our codes, starting from the 5 parts down to the print file. All right, thank you for this. Now moving on to the second code. I'll be reading the second code now, and the second code is we're having a question. I was giving question 280, which says store MIC values for different antibiotics in a dictionary and display them. All right, for my code here, I'm giving the step 1 is to create a dictionary to store the MIC values for antibiotics. So on number 2 column, I'm giving the mic underscore values equals to brackets, and then I insert the amoxicillin, which is 0.5. Then number 4, I'm having the ciprofloxacin, which is 0.25. Now on the 5th column, I'm having the LT-omycin, which is 1. And on the 6th column, I'm having tetracycline, which is 2.0. I'm going to be starting my number 7 column, which is the gentamicin, which is the 0.125. Then on the number 8 column, I'll be inserting my vancomycin, which is 1.5. And on number 9, I'll be inserting my chlorophenol, which is my 8. On 10 with the brackets, then I move to 12. So step 2 is I have to display the MIC value for each of them. So this time it's time for me to print out my values now. So the next step I'll take is to insert print open bracket MIC values for antibiotics open bracket in ml and gl, okay, or close bracket. And my number 14, I'll be having for antibiotics MIC in MIC underscore value dot items in bracket. And my number 15, which is the final stage, is for me to finally print out, which is print open bracket F with an hyphen open bracket antibiotics close bracket dot open bracket MIC close bracket the UG and ML. So now this is just for us to print the value of these drugs, because we are creating a MIC value for the antibiotics. So these are things that we'll be mixing. These are things that these are the essential materials. These are the essential things that we have to put in place for us to be able to produce the accurate MIC values for the antibiotics, because each of the numbers speaks accuracy, speaks the numbers of the numbers of quantity of each of the ingredients or each of the products that should be added as MIC value for the antibiotics. Yeah, so as we have printed it out, when we run the code, we'll be having the accurate value for each of them. And thank you so much, and I really appreciate. So till the next time, I will say thank you so much.